Welcome to your IELTS listening practice from Spinta.org. This is a mini-test designed to help you practice a specific section of the exam and improve your confidence. The recording will be played one time only, just like in the official test. Let's begin.
Welcome to today's discussion on space debris, one of the most pressing challenges facing modern space exploration. Since the launch of Sputnik in 1957, humans have launched thousands of satellites, spacecraft, and rockets into Earth's orbit. While these missions have revolutionized communication, navigation, and scientific understanding, they've also created an unprecedented problem: a growing cloud of orbital debris that threatens future space activities. Space debris, often called space junk, includes defunct satellites, spent rocket stages, fragments from collisions, and even tools dropped by astronauts. Currently, there are an estimated 34,000 tracked objects larger than 10 centimeters in Earth's orbit, with millions more smaller pieces that pose significant risks to operational spacecraft and the International Space Station. The primary danger comes from the incredible velocities involved. Objects in low Earth orbit travel at approximately 28,000 kilometers per hour. At these speeds, even a paint fleck can damage spacecraft windows, while larger debris can cause catastrophic collisions. The 2009 collision between an active communications satellite and a defunct Russian military satellite created thousands of new debris fragments. The Kessler syndrome represents the worst-case scenario for space debris. Proposed by NASA scientist Donald Kessler in 1978, this cascade effect describes how collisions create more debris, which increases the probability of further collisions, potentially making certain orbital regions unusable for decades. Some experts believe we're already experiencing the early stages of this phenomenon. Low Earth orbit, where most satellites operate, is becoming particularly congested. This region, extending from about 200 to 2,000 kilometers above Earth, contains the majority of operational satellites and debris. The increasing commercialization of space, with companies launching large constellations of small satellites, is exacerbating the crowding problem significantly. Tracking space debris requires sophisticated radar and optical systems operated by space agencies worldwide. The U.S. Space Surveillance Network monitors objects larger than 10 centimeters, issuing collision warnings to satellite operators when necessary. However, the vast number of smaller, untrackable fragments poses an ongoing threat that cannot be predicted or avoided. International efforts to address space debris include the development of guidelines for responsible space activities. The Interagency Space Debris Coordination Committee has established practices like the 25-year rule, requiring satellites to be removed from orbit within 25 years of mission completion. However, these guidelines are voluntary and not legally binding. Active debris removal represents a promising but challenging solution. Proposed methods include robotic spacecraft that could capture and deorbit large debris pieces, ground-based lasers that could nudge objects into decaying orbits, and magnetic systems that could collect metallic fragments. However, these technologies are expensive and technically complex to implement. Prevention strategies focus on designing satellites with end-of-life disposal plans. Modern satellites increasingly include propulsion systems to ensure controlled re-entry or movement to graveyard orbits. Some companies are developing satellites that completely burn up during re-entry, leaving no debris behind. Standardizing these practices across the industry remains a significant challenge. The space debris problem illustrates the unintended consequences of technological progress. As we become increasingly dependent on space-based services for communication, navigation, weather forecasting, and scientific research, protecting the space environment becomes crucial for maintaining these capabilities. Solving this problem requires unprecedented international cooperation and innovative technological solutions.
You have now completed the practice test. When you are ready for a full exam experience, visit us at Spinta.org. There you will find complete mock tests for all 4 skills: listening, reading, writing, and speaking. Our platform provides instant AI feedback for your speaking and writing tasks, along with an accurate prediction of your band score. Take control of your preparation at Spinta.org.